A club consisting of 11 men and 12 women need to choose a committee from among its members so that the number of women on the committee is one more, let me just highlight that, one more than the number of men on the committee. The committee could have as few as one member or as many as 23 members. Let's have the value of n be the number of such committees that can be formed. So if n equals to a choose b, which could also be rewritten in this notation, we are asked to find the value of a plus b. So before we move on to any actual math, let's just come up with the scenarios that can be possible for this. So we are said that the minimum for this committee must be one member, which means we could have one woman on the committee and then 0 men on the committee. And then moving on, we could also have 2 women on the committee and then 1 man on the committee because the number of women has to be exactly 1 more than the number of men. So we can keep moving forward with this pattern until we reach the maximum amount of women, which is 12 women and 11 men. 12 women would be the maximum number of women because if we have 13 women, that means we would have to have 12 men. So if you have 13 plus 12, that would be 25, which is greater than our maximum, which is not possible. So now that we have all of these scenarios listed, let's think about some combinatorics we can use for this problem. So we know that we could have a maximum number of 12 women. And if we look at this scenario specifically, we are asked that of these 12 women, we need to have 1 woman to be a part of this committee. So this would be 12 choose 1 plus, oh wait, not plus yet, sorry. So we have that as our first combinatoric. And then with 12 women, we have 11 men total. And then we're choosing 0 men from that 11 men to be part of this committee. So that will be our first set over there. And then moving forward, looking at our second scenario, we could use the same idea that, okay, we have 12 women total, and now we're choosing 2 to be a part of the committee. And then of the 11 men we are choosing 1 to be a part of the committee. And now we can keep moving forward with this equation, but we see that the final combinatoric set that we get is that of the 12 women, we have all 12 women participating, and then of the 11 men, we will have all 11 men be part of the committee. Okay, now how exactly could we go about finding the solution given all of this? Well, we know that the total number of people on the committee, the maximum number we have is 23 members. So which means that we should have a 23 in our A value to find the maximum. So what we could do to get the A value of 23 is that we could group the first term and the last term together, because clearly we see that 12 plus 11 gives us 23. So we could just rewrite this combinatoric expression as 21 choose 1 with 11 choose 11. And then we would also group the second term together with the second to last term together. So plus 12 with 11, choose 0. And then we can keep on moving forward with this, but instead of rewriting the whole thing, a quicker way we can solve this problem is by simply noticing a pattern. So as we've established, we see that our A values always add up to 23, which means our final product must have an A value of 23. And looking at the bottom values, the B values, we see that 1 plus 11 and then 12 plus 0 both give us a final answer of 12, which means this is the final combinatoric we get as the answer of this problem. However, we're not done just yet. We found the value of n, but now we need to add our A value and our B value. So 23 plus 12 gives us a final answer of 35.